Okay, using the notation of the textbook from page 520, the initial point of a vector, let's call it Q, and the terminal point, initial point we'll call P, the terminal point we'll call Q. And basically point P would be considered to be P1, comma, P2 as a point, and Q we'll call as Q1 and Q2. Or Q sub 2, I guess would be proper. So if I want to talk about the vector PQ, starting at P and ending at Q, initial point P, terminal point Q, I can write it in the vector notation, all right, or component notation, and I do Q1 minus P1 and Q2 minus P2. Basically, when you're writing it in the vector component form, you always start with the terminal point minus the initial point. So that's why the direction is really important, because your numbers will be positive or negative depending on your direction. This notation could also be written as V1, V2. It could also be written as a heavy print small v. Okay, small alphabet letters are used to denote vectors, and they're usually bold in your textbook. Now, I can find the magnitude of a vector, and the magnitude represents the length of the vector. So the notation for magnitude of that vector v would be 2 bars like this, the vector v, and then 2 bars again. That's notation that means magnitude. So the magnitude for the current vector is the square root of this plus the square root of this. So the square root of Q1 minus P1 squared plus Q2 minus P2, squared. That's the magnitude. I could also represent it by saying V1 squared plus V2 squared. This is easier to use, of course. And if there's a special situation, if the magnitude equals 1, the vector has a special name. It's called the unit vector. Just like the unit circle is based on the unit 1 going around the circle. So the unit vector, if you're doing the magnitude of a vector and you come up with the answer as 1, then you know that you have the unit vector. And that's kind of an interesting thing that will be able to be used. Now, I also want to talk about equal vectors. All right, so let's talk about some vectors and see if we have equal vectors. All right, so if I want the vector name for PQ, what do? Terminal side minus initial side. So let's put it in vector notation here. 3 minus 0 and 2 minus 0. So I get 3, 2 for the vector PQ. What do I get when I do vector RS? Well, let's do that. RS equals 4 minus 1 and 4 minus 2. And what do I get? So vector RS is 3, 2. Those vectors have exactly the same name. So I can say that PQ equals RS. What would vector SR be? SR, that means R is the terminal point, so I have to go 1 minus 4, and I have to go 2 minus 4. And what do I get there? I get -3, -2 for vector SR. Is vector SR equal to PQ? No, it's different, okay? So equal vectors look exactly the same when you put them in component form. All right, let's take vector UV. If I did vector UV, right, UV, let's do it over here, UV. If I'm doing UV, I have to identify which point is the terminal point because I start with the terminal point, remember that? So that's the second point. So I do 1 minus 5 and 3 minus 8. And what do I get? I get negative 4, negative 5. Is UV equal to SR? Nope. They're both negative, but they're not equal. Does UV equal any of those vectors? No. So equal vectors have to come out exactly the same. So these are equal vectors here, all right, PQ and RS. And I can write it like that.